Hello, everybody. We are Fluid Mechanics Team 2 from Section 4, and for our presentation, we chose to present about fluid body armor.
Basically, the shear technique is the fluids are promised by using the colloidal suspension of the solid particle in the Danielwicz matrix, and we can call it the lantern fluid due to the unique property. Many believe that fluid can be used in the field of the body armor. We can understand it the hot particle that's suspended in the polyline glycol and insect non-toxic thickness that's using in a variable of the common product like some ice cream or ketchup. Modern synthetic fluid are made from the ceramic nanoparticle that are heavily loaded in a Korea like with
When impacted by the extreme amount of force from the projectile, the STF hardens. The STF hardening is it changing from a liquid state to a solid state. This spreads the impact over a greater area. This adaptation occurs so quickly that it stops the projectile before it can actually damage the person with the armor on. STF body armor is composed of polyethylene glycol, which is a polymer that suspends the silica particles in the armor. Shear thickening fluids, and Kevlar that holds the shear thickening fluids in place where necessary and to also provide additional protection. STF body armor is still in its early stages of research, with the earliest research dating back to 2003. Research has been conducted at various institutions, including the University of Delaware, the U.S. Army Research Laboratory, and Mortex Institute of Security Technologies in Poland. Mortex Institute is the closest to creating this product, with a model succeeding to function with projectiles at a velocity of 450 meters per second and higher. The main goal of this research is to create STF body armor that is similar in strength or improved upon when compared to Kevlar vest.
So as James just stated, the main goal when looking at STF body armor is to make sure that it's equally strong or stronger than the traditional Kevlar vest, which are used now. So in order to compare these two, there are 4 major tests that are done on both types of armor, and then the results are sort of compared with one another. So the first type of these tests is the common ballistic test, where a projectile is fired into the material, and then the amount that it penetrates through the material is measured and recorded. The second is the tower drop stab test, in which a sort of knife almost is lowered and stabbed into the material, and the impact force is determined by this test. There's the quasi static test, in which the material is placed inside of a large machine where 2 pieces of metal compress the machine. And then again, it's sort of a way to determine the impact. And then finally, the flexibility test is done in order to determine basically how flexible the material is in order for it to properly be made into vests so that soldiers can actually wear them. So in all 4 of these major tests, STF armor proved superior to Kevlar, and research has shown that using only 4 layers of STF treated Kevlar is comparable to about 14 layers of just using base Kevlar in terms of impact. And when looking at the picture there, which is from a tower drop stab test, it's clear that STF Kevlar seems to be superior.
So is STF armor actually being used? Unfortunately, at this time, the STF treated Kevlar and STF body armor hasn't really had any practical combat use. This is due to the fact that STF treated Kevlar is actually heavier than Kevlar on its own. The Mortex team in Poland is actually still researching this idea of STF armor to actually get it into use in the future. And they feel as though they've actually found a solution in armor only composed of STF that's stronger and lighter than Kevlar actually infused with the STF. They're also examining different fluids for use in body armor, one being the magnetorheological fluid, or MR. they hope to be applied in their products soon because it's actually oils and it's filled with iron particles. So when exposed to magnetic field, the particles are going to line up, thickening the fluid dramatically. But there's still a lot more research that's needed to be done before any of these are put into use. So thank you for listening. And on the next slide, here's our sources used.